Hello. So I noticed tonight that Brian's outnumber everyone else. Brian, any other Brians? And the thing Jason forgot to ask is who's here for the free beer and free food? I knew he was going to raise his hand. My good buddy Tom. So cool. I have the privilege of knowing almost everyone in the room. I didn't get a chance to meet you or the fellow next to you who's like, maybe this guy can hurry up. So I will do my best. I'm Brian. I'm from a company called MadGlory in Saratoga. I'm an engineer. A bunch of my friends are here tonight and my colleagues. Jeff's here. Hi, Jeff. Patrick is here. Hi, Patrick. Tom's hiding. Hunter here. We sometimes get to borrow Hunter when he's feeling okay for us. And Chris, of course. So in our office is MadGlory, and I am an engineer at MadGlory. And Networks, which Jason mentioned, which is our sort of TV platform company, which Chris runs, and I think he talked about last week. So I'm going to jump back and forth because I don't have like a slide thinger. So
there's one right there if you want to grab it.
I'll screw it up. All right, cool. So this is just a couple opening slides. This is from our official deck. So what is a game platform? So basically, they refine a little bit, but we make game platforms for companies. Most of our customers are out west. They come to us because we have this really strange niche in building software that runs at, say, 100 million plus users. And we've got about, 10, 15 years experience, depending on how far you want to count back, of gaming stuff. And we're in Saratoga, which is really weird. We have basically no competition in the entire world that I've met ever yet. Maybe these guys in the UK called the Fire Team, but I don't know, we've never come up against them, but I suppose they must exist somewhere. So the type of stuff we tend to do, we make back-end services, so this would be like tournament engines, stuff that makes your game work. Anyone play Guitar Hero, they're a kid, or adult like me? All right, cool. Saints Row, Mortal Kombat, anything from 9 on, Call of Duty 5, Saints Row, probably mentioned that, Shadow Mordor, our biggest one, League of Legends, which is the one I'm wearing tonight, that has like 150 million monthly users. We build services for those types of games. So, past this deck tries to sell you stuff, so I'm going to switch it. I'll read my stack a little more. Cool. I like to have a lot of tabs. I know I've been making fun of him talking for work. I work for this all the time. Is that kind of coming up okay? Cool.
Yeah.
Nice. So, in our main line of work, we're a consulting company, for the most part. But, in a past life, in several past lives, we've actually licensed software, like probably many of you. So, we're sort of in the middle of rebuilding our own licensable game platform. And the idea is we build it, and we license people the source code, so they actually get the source code, and they pay us every year for updates to the source code, which is a kind of a nice model. You don't have to host stuff. There's no waking up at 3 a.m. I have 3 kids and a wife who loves me occasionally, and so she really does not want me getting up at 3 in the morning. So she likes to sleep too. So our newest platform is called Space Whale, and we named it Space Whale because Space Whale is a being of immense size and awesomeness. If you didn't know that. So, keep in mind they're game companies, right? So a little bit, Chris and Jason asked me to come in and talk a little bit about Go, because we're in a Google meeting, and talk a little bit about kind of what we're building, again, for the second time or third time. Kind of a little bit about why we're doing it this way. So we have the interesting experience of like having built the same thing many, many times now. So not everybody gets to do that in their career, and I'm talking like over a decade and a half. So you start to pick up some tips. You remember all the things you fucked up, basically. So what is Space Whale? So Space Whale is an online service platform. It's really a microservice chassis, which is, if you're a developer, it's sort of like a toolkit for rapidly building microservices. Rapid application development, I suppose. But the idea is to specialize in microservice stuff that's horizontally scalable to at least 100 million users, be able to be deployed in a wide variety of crazy, fucked up situations. Like I've seen things in real life with deployment stuff. You guys know, you see worse things every day. That's a little bit of what we can deal with. So So for instance, we want to be able to deploy to containers, which is sort of like our ideal, like, great. VMs, okay, we can press images. We want to be able to install the bare metal, pretty much anything. And so we want to support multiple interfaces. So we support HTTP over JSON RPC, which is HTTP1, or HTTP2 over gRPC, which is actually the thing that Google's doing that I'm most excited about. I'm not going to talk about that too much tonight, but if you haven't looked at gRPC, it's the shit. So worth looking at. And also using messaging back and forth over some to be determined bus. So imagine you're going to sell software, right? And you have, like us, 8,300 potential clients in the entire world. So you can literally plot on a map where every one of your potential customers are, and every one of them does something different. Game companies are not particularly sophisticated. They're really good at making games. They're really awful at everything else. Sometimes they're good at marketing, but usually they're not even really very good at that. So from a technical perspective, we just walk into crazy stuff. Our current one, this game supports 90 million users a month, and they're manually rsyncing their Python files up to restart their servers globally. So that's not like just NA, that's like in China, which is crazy to think about. But also, if you don't know this rule yet, Janet, this is for you, or every future student for you, the world runs on horribly shitty source code. I think you probably know that. But the actual world runs on shit. It doesn't run on beautiful, well-tested, eat off the plate code. It runs off shit. But that's okay, because shit can be beautiful too. Let's just let that one go. Cool. So Space Whale, inspired mostly by Netflix and some of the stuff they've been doing for the last, decade. We borrowed a little bit of the ideas from Go Micro and Go Kit. These are things that have been inspired in the community. We decided to build our own. Go is a really nice language with a really great library, and it makes it easy to build your own stuff. So we just decided to go it ourselves. Plus, we wanted to write every line from scratch. We wanted it to be fully licensable. We didn't want to have any concerns about what we were doing. So we wrote most of it ourselves. And I'm really glad we did, because I think we made some better decisions than both those guys. So this is the New York Times, and they made some really awful decisions. You can go look at theirs on the website. And GoKit is like a science project that no one's using. So there's a space whale. Keep your eyes open, there's going to be more. Okay, so a little bit about Go as a language. Does anyone use it on a day-to-day basis? You probably know more than I do. I've been using it for about 4 months. I know this guy, he's a smart guy. But I'll tell you what I know. So anyway, it's a nice statically typed language. It's a very tiny language spec. It's about 70 pages. Under active development, it's still at that point. If you can tolerate it with the language, like there's new versions coming out every 6 months or a year or something. It's got big company support, which is all why we're here tonight. And it's got this couple nice features that if you're a curmudgeon like me, like no polymorphism. Polymorphism's the worst. No inheritance, also the worst. It's like the second. It actually might be worse than polymorphism. It's the worst. So Go is a very, very, very simple language. Like when you're bored tonight, you're on the couch, download the language spec, you'll have it done by the time you go to bed. It's heavy reading for what it's worth. The language is written by one of the guys who wrote C. So it's, he doesn't fuck around when he makes a language, but it's nice and concise. Another space whale. The guys in the room will know we're working through our branding process right now, and we've hired a key art artist who does crazy gaming art. So I'm not trying to help us decide what we want to do. Cool. A little more about the language. So it's got really cool built-in concurrency primitives. Yeah, everybody likes fast things. We always hire new people on, and we always laugh all the time at how much they talk about, we can make this slightly faster if we use this instead of, that's stupid. Micro-optimization's dumb, right? Total waste of time. But concurrency primitives in Go are actually really cool. When you're dealing with the size and scope that we are, one thing you want to do quite frequently is completely utilize a server, and you want to share memory. So running like 25 Python processes, or like, I've got a 36-core server, so I can overload it with 50 processes and use, whatever the threading thing is. What's that we call it in Python? The mutex? Yeah, it's got that library. Anyway, any Python people? Okay, forget it. Doesn't matter. But we just did this for Super Evil Megacorp, which is one of our customers, and oh man, not being able to share memory between processes is a nightmare doing the stuff that we're doing. So like for instance, this one was this project I'm talking about was a match width time estimator. So we take all the data about the time that it takes someone to get into a matchmaking queue in a video game. We use it to predict future times. That each CPU then requires this giant shared memory structure, which like in a language like Go was super nice. And we were actually checking to see who could do it faster. Tom wrote Python, and I wrote in Go, and we were playing golf back and forth every day. And he was like, I shaved off 20 milliseconds, and I was like, oh, I shaved off 15, and we had a lot of fun until the client was like, I will only accept this in Go, and so I got fired. But anyway. Cool. So really discourages simple over clever, discourages bike shedding. What's like worse than sitting around your company and like, oh, let's have a conversation about, you know, the way we're going to format our code. What a fucking waste of time. Like in Go, that's all fixed for you. You're just running Go code, it's done. It's a total waste of time. And in fact, if you're still doing that in your company, like be the guy who stands up and says, we have better things to do, because you do. Who cares if you're right or wrong, as long as it's the same. There's really nice conventions like capital versus lowercase functions. Capital, public, lowercase, private. Done. A really nice standard library written by Google's all the way since back in like 2007. Like if it's been done over a network wire, Google's doing it and they know more than you do, it's good enough. Like it's great. And it's sort of the bastard child of C, Java, Python, and maybe Dash. I don't know, I made that up, but I think that's true. It's another space web. So he's creepy. Cool. So tooling. This is where like I think most people go right away. Like they run into some shit. The way you structure your project is really, really weird. I have a mostly background in dynamic languages, like probably some people, actually a lot of Java people here, but many people. The way that they do workspaces is weird. So Google, very opinionated. You have to have a hard-coded path, everything, libraries, compiled binaries, everything's in the path. But after you kind of use it for a while, you're like, all right, I see what they did here. Like, yeah, they got sick of Python having everything kind of global. They kind of wanted everything like user land in my own directory. And they're like, yeah, they kind of want everything compiled in like C. So let's just like mash those two things together, and boom, you got the plan that they can go. This is probably the piece that's evolving the quickest. You see this changing all the time. There's absolutely edge cases on this stuff. Another weird thing is, the Go project, every folder is essentially its own package. It's really weird, because you know, like in JavaScript, Python, you're like constantly kind of refactoring things and diddling around with what's going to be in one folder, and how you got to reference and name stuff. In Go, if you do that, it's a new package. So like, it's very specific that you're going to do it on purpose. However, that restriction, while being a little annoying, turns out to be super nice for a lot of other reasons, which I'll mention later. So yeah, dependency management is rough. It's not built into language at all. Google's plan is, if you have a library and it's a dependency for your app, you will check everything in the source code. So that's everything. So a lot of people, if you're, let's say, a Node developer, you probably hate checking into source, right? Because it's like a billion files, especially in Node. Or Python, you know, got that virtualized stuff, which is like a hack on a hack. Or Ruby bundler, I guess. But imagine checking all that stuff into the repo. It can make a lot of crap. And it's awesome when somebody uploads a library, they have 19,000 files changed, and they don't know how to make that a single commit, like me. So that's a total miss. Because then it's like, I fixed this thing, and there's 20,000 files. But the cool thing is, Go is a compiled language, and it compiles the damn near everything. Which is why you see companies like HashiCorp, if you happen to use Docker, everything's working Go, right? It works everywhere. You can compile a language. Another space whale, that's from The Simpsons. Never saw that episode. I did it. I wish I could say I did. Use some glasses there, Fred. So this is a little bit about kind of what it's like to use Go on a daily basis. So it has this really awesome built-in package called XBAR, which if you load this thing, runs a web server that exposes metrics for your app out of the box. It's great. GoFont is a automatic formatting tool. If you write it, it just auto formats everything. You can't control anything. It's done. The code linting stuff, kind of built into GoFont, is pretty awesome. It's got coverage tools built in, cyclic dependency checkers, documentation checkers. All this stuff is pretty much, if it's not in the Go tool, which is the standard one, like it's in the packages that everybody uses in every IDE ever. You're going to find that like Go code generally looks the same no matter who writes it. Which like, when did you last say that about anything? I did a lot of Java for a while. Like, you can't take two Java programmers, set them down next to each other, make them work together, and have anything look the same. It all looks different. Also, stuff like metrics are pretty awesome. So one thing that's kind of, oh, let's see, another space well. There you go.
I like that one.
Yeah, he's my favorite. So he's kind of our leading one for like what our mascot ought to be like. I like him because he's kind of funny, and it's called Space Whale. It's got to be something fun. We just wanted him eating that satellite, but then it would break too fast. All right. So a little more about Go. Like, we're not building web apps again. If you're using Ruby on Rails, like, congratulations, you're still using the best tool that was ever invented, as far as I know, for building web apps. There's never been a better one. But in Go, you're building microservices, you're building command line tools, network services. If you're doing that stuff, it's the shit. It's got a really, really lightweight dev environment, so if you're one of those IDE people, you'll be super happy. If you're one of those non-IDE people, you'll also be super happy. If you're like an Emacs or a Vim guy, I suppose you'll be happy too, but I don't know, I'm not one of them. So it really grows pretty well with you. Really, interfaces are sort of the main part of the language. Sorry, it's sort of a cursive real quickly, but interfaces are sort of done for everything. The way that Go does interfaces, if you use them in Java, you don't have to implement an interface. It's just if you happen to comply with it, you've done it. Like, you did it. Congrats. That's it. So if the interface says you need 6 functions and you have those 6 functions, that's all you have to do. So that's kind of a neat part of the language. Testing is really, really, really cool. You write your test files right next to your file. So if a file is _test, it's going to be run. And so if you have like service.go, right next to that you have service_test.go. They're in the same folder and they're in the same package. You don't separate them. You can, but you don't. And that's one of the reasons the packaging stuff is actually really awesome. If you get a package, it's completely self-contained, and everything's sort of within the same scope and gets to access it right there. It's really cool. Same thing with benchmarking, which I hadn't actually seen in the language before. If you do service_benchmark, and you start your functions with benchmark, when you run go bench, it benchmarks. Really awesome when Tom and I were playing golf. In fact, I felt like I was cheating sometimes, because I had my benchmark test, and I was like, Tom, it's this much faster. And then, of course, the client. But, you know, anyways, it's a really cool feature. That's a cool one. Yeah, I don't know how you pronounce things. All right. Tips. So this is sort of like my 5 pages of like little things I've learned in Go. But also, over the years, I think things that myself and the rest of my buddies here have sort of figured out over how to build really, really scalable services. So I guess this first one at least is Go specific. You know, one thing when you build like say a Node app or a Python app, you're sort of used to like distributing the folder, right? Go is a compiled language. You need to think about it in terms of everything I do should be able to be compiled down to a single file, which really changes the way you think about a lot of things. So I'm actually supposed to say, it really should say compile everything. So for instance, have anyone ever written a migration? Ruby? Mark? Yes, of course, I know you have. That's right. You can't do that. So let's say you want to upload your project to the server. You can't have a compiled binary that requires some folder sitting there, a whole bunch of .SQL files, right? In Ruby there are but in Go, so the idea there would be you want to compile those dependencies in. It still should be a single binary, which is weird. It also gets weird to things like configuration files or how you're going to do some of that type of stuff in your app. And really, at the end of the day, you want to build assuming that you're going to have a single file, which changes the way you think about a lot of things in the world. So things like migrations, fixture files, everybody compiles their fixtures. So you either optionally compile them in or not, potentially, build it depending on your build process. But let's say you do. So we have one that compiles a 1,000,000-line JSON file into a binary compressed Go file. It just seems weird. Like, why would you waste all that space? But that's what we do. So you kind of need maybe sort of an overlay in the standard tooling a little bit because you do end up doing a lot of scripting. We use Make. I think at least in industry we're seeing Make pretty much everywhere these days. I don't know what you guys see, but if people run largely Unix system, everyone's kind of falling back on Make because I think everyone's sick of loading up a node thing and having to know how to do npm start and then Ruby one and bundle exec. And so like, at least for us, doesn't matter what language it's in, there's always a make button. Make install, make deps, make run. It's always the same everywhere, regardless of language. It's a super sweet tool. It's great for the DevOps guys. They love this stuff. It's also great for the developers because there's so much cognitive overhead in switching. And like, who wants to read the README, go through, what is this about? How do I do? So finally get to the development section and then find that out. Like, I just want to go to the make file, look at it, and see it work. That's it. Make it simple. So we use make for everything now. If you're writing APIs and you haven't read the 12-factor stuff, it's probably time for that. We generally follow that for everything. I think Corrigan published that, right? Yeah.
They reference it from all the docs.
Yeah, they reference it from all the docs. So this is like 12. This is like a 12-step thing that's going to make your life a lot better. For instance, if you were pushing metrics, that's a dumb idea. You want to let metrics be a pull. That's all the 12-factor stuff. It explains why, and it makes a lot of sense, particularly in our case where we're sort of invading these foreign environments with our software. We always use these .env files to kind of make life simple. One thing I learned the last 2 weeks, those are executable in Bash. You can source them. Like, yeah, you guys do that. DevOps guys do that. But like, that's actually a pretty cool trick. So all of our make files source the env file, and then we usually source it within each declaration of task within the make file. And that's really nice. And then in production, we assume those environment variables are going to be set in the production environment. So say Docker, we can just settle that. Everyone's waiting. Are you ready? Ready? Next space wheel? Oh, that's a letdown. Oh, that's a letdown. I'm sorry. Should try harder. I could have made that one. All right, cool. So another thing, so one thing that's really cool about Go is it has this concept of channels. So if you've ever used a message bus, let's say RabbitMQ or a queuing system, everybody, you know, for the most part, will run into that in their career if they haven't already. Go basically has all that kind of internal to language, which is awesome because you can model everything like a giant messaging system, even in your app. But don't do that. Because it's like total overkill and it's completely impossible to reason through things. You know, you're like, where did this message come? It's nuts. But you can do it. And so what we tend to do is if there's sort of large pieces of the app, we do that. And we try to have channels, and you can sort of create a function that takes, for instance, a channel, which is really cool. And then you can have a function return a channel. So kind of neat way to think about the world. So we do that with large portions, and you do that so you can really max out CPUs. So, you know, when we were building that match wait time estimator, we built sort of, you know, you always build the dumb version first. So we built the naive version first, and we fired it up and we ran it. We said, wow, this is completely maxing out one of our 36 cores. So then we built in some of the channel stuff, and it got a lot higher. We built a little more, and it got higher and higher until finally you're 99%. Like, this computer cannot go faster. Math cannot be done faster than math. So that's a really cool thing. Sorry, I'm looking down at this point. That must have been South Park. Yeah, I'll have to look that one up. But he's an orca. That's kind of cool. All right, this next tip here. So Docker and Docker Compose. I'm very new to Docker, but you know, as is the case for most of our work, like when we get thrown into something, we just say we already know how to do it, and we just go figure it out. So now we're Docker experts, but we've been using Docker Compose for local development on this project, and actually basically every project now uses Docker within the last 2 months, which is awesome. So you remember the days where you had to do stupid things like stuffing up database calls? Goodbye. Like, you don't need to do that. Use Docker to guarantee that your local dev environment looks exactly like production. You might still use things like fixtures, which you should, if you need a database, you just guarantee the database is always there in local development. Done. Like, that always felt awful. You know, that always has mocking and stuffing and doing all this bullshit on databases. You know, fake redises and all this stuff. Oh, it always felt awful. It always felt like an awful hack that somebody like up on a podium is telling you should do, and you're like, yeah, but the real world disagrees with you. The real world is right. It's an awful idea. Great about Docker. You don't ever have to do it again. That's a little better. That's a key way to play it. Cool. So Heroku has some really nice public patterns that I get started with Go. They have this idea of a command folder, which is actually really cool because Go apps, if you have a main function, will compile to a binary in your Go path. Problem is, like, most apps really have more than one. So, like, most of our apps would say have something like, you know, start the server, or run the migrations, or maybe start up a client, or we actually have most of ours, you can either start them with gRPC as a protocol, or you can start them with JSON RPC as a protocol. If you're using REST for internal APIs, talk to me after and I'll tell you why that's a bad idea too. But so what it usually does one of those two things. And so having this command folder is really nice because when you compile them in your binary directory, you get bin, command, and then the name of your thing. It's really cool. And you can thank the road for figuring all that out. And you can imagine why they had to figure it out. And I'm sure Apprenda has to figure this kind of stuff out too. So ask Mr. Miller there if you want more to get to that. Cool. So here's another whale. Zoom that way. Yeah, it's like claymation. All right, cool. So tip number 5, just like if the tooling exists, just use it. There's like this package called Go Plus if you use Atom or Sublime or anything, just install it. The first couple times you use it, it'll drive you crazy. So you'll screw up indentation and you'll be requiring a library that it turns out you don't use. You hit save and all that code just disappears. And you're like, ah. The minute you hit save, it fixes everything. So it's actually super cool once you get used to it. When you first get started, it's like infuriating. And you don't hit save until you're done typing the thing you're typing because otherwise it just disappears. But it's kind of cool. The community is really interesting because I feel, Google's out there doing, they have a very set way of working with Go because they've been doing it for almost 10 years now. You have newer companies like Docker or HashiCorp, uses it for almost everything and they have a different way of using it. And then you have a lot of other companies who are starting to pick it up in the service business because they're going Docker-based. And it just makes a lot of sense. And those guys are using it even more differently. So it's interesting to kind of come in and see how the language is converging on all these different groups. There's also that really fun time in the language where you get in early and you can maybe still have a voice. And remember when all like early Ruby podcasts came out and like there was key members of the Ruby community, like you're there. There's no Go podcast. There's one. It sucks. It's like 5 minutes long.
Can I just bring something up?
Yeah.
So we're actually working with in Hudson Valley with their GDG chapter down there.
Sure.
Get some focus from the Go Bridge people, led by Brian Kettleson and also Bill Kennedy, both of which have either written books on this topic or thought leaders or
His
community
podcast is
leaders.
like the only good one.
No time.
Yeah, Jason got me into that one because I was complaining one day. He's like, well, there's one, and here it is. That's it.
Yeah.
But it's a great time to get into community. I mean, I just remember early days of like Node.js. If you're interested in this stuff, you don't the opportunities don't come along every day so early and really influence where it goes. For instance, in our system, we want to use this thing called flat buffers. It's a serialization technology that Google actually made for Android for gaming. So of course we love this stuff, right? And we use this other one called protocol buffers, which Google also made, but it's not quite as efficient. So there's a plan to bring some of those flat buffers in, and I went in and +1 this thing on GitHub and said, yeah, we really want this because we build game shit and we build game platforms. So a couple days later, we got a call from Google like, hey, can you write up an article on what you guys are doing? It'll be the first case study. Like, we're not doing anything in production. We're not doing anything that interesting. But like, this is where the community's at. Like, if you're doing anything that's not Docker, you're pretty much guaranteed to have some interest in what you're up to. But a lot of databases. So if you use InfluxDB, which is like my favorite one right now, Aerospike, which is probably my second favorite one right now. Both those guys are all ready to go. There's implementation of LevelDB, BoltDB, all those natively in Go, which is really cool. Last whale. I just thought that was pretty epic. That was the most one. That's it for me. So if you're interested in this stuff, you can find me here, Brian at MadGlory. Go to our website, Brian at MadGlory. Or hit me up on Twitter. Or if you play video games, Xbox, PSN, Steam, League of Legends, MadGlory. What else do we play? We have to play more to get paid for it.
Rocket League?
Rocket League? I'm shitty, Rocket League. Hit not Josh Cookfair on Rocket League. But pretty much anywhere on Steam. It stands for General Assembly. Thanks.
Let's do a couple minutes of QA. No one's got any questions, Brian?
Hey.
Hi.
Excuse me.
Jim.
My name's Brian. What's your name, sir? Hi, Mr. Cifarelli. Nice to meet you. We go back like 10 years. Okay.
I'm not a Go programmer, I've never used it. But with respect to channels, is it something for messaging between running compiled assets? Or only within a single compiled Go thing like Ready or something?
So it's not like Erlang, where if you run multiple Erlang things on multiple PCs, you can kind of stitch them together through the actor model. It's not quite like that. It's really mostly on one server, but you can use it to sort of handle the concurrency and parallelism stuff that sort of comes up on some certain types of apps. You know, we find like, if we're writing a web app, you don't need all that shit. I mean, you just don't. In fact, it's probably overcomplicated. But if some of the server stuff, where you're basically trying to make 100% of these resources on the server available as like one thing, it's really great for that. Yeah.
Actually, if I could get very honest.
Please do.
Channels and code teams, which is the kind of the way that channels communicate with asynchronous processes, are a production of something called sequential. It's called the CSP. We should understand what it's concurrent sequential multiprocessing. Basically, it's a way to kind of reduce distributed problems into something you can build a formal specification for. It's not a full implementation of them, but it's a partial implementation of one idea, which is basically that if you have a channel coming into something and a channel coming out of something, and you don't say, go do this operation, you say, here's some data. You can then also listen to the outgoing channel and say, I'm going to get some data. So you can use the channel and the fact that you're picking a piece of data off of it, along with a timeout and the expectation that your code might block. You use the channel, you put information into it asynchronously, and you take information off of it, you might block it. And so what you'll use them for is a lot of times you might make a channel with only one thing in it, and spot a bunch of coroutines with the intent that each of those coroutines is going to call you back on the same channel. You just did a fan-out operation.
MapReduce kind of thing.
Exactly. So you can do pretty much anything you want to do inside the memory space with concurrency, with coroutines. You can also screw it up massively. It's not a great abstraction for everything. Go does have all the concurrency primitives you want, like monads and like mutexes and semaphores. But it is probably a little bit more powerful to program using channels and coroutines because you don't have to do all the manual labor of managing mutexes and so forth. I'm an actor guy, and so I wish there were actors in the language, but having coroutines is close enough.
We have a list of freedom.
Thank you.
I haven't drank that.
You guys know any good references on buffered and unbuffered channels and how to select the number of slots in a buffer channel? Or is it really empirical?
I don't know, the way we do all this stuff is just like, we try to figure out a way to write benchmarks and tests and just try one thing over another and just try it.
Yep.
So, yeah. That's a really great question.
There's a good answer. I can't say. It depends on the type of data you're putting into it.
I mean, our use case for this was almost perfect. So, you know, again, imagine you got a 36-core server and you're writing a Node.js process, right? And you have this piece of memory that has 10 million entries in it. And so what you have is somebody where, let's say, a couple hundred times a second is changing that memory structure. And then the same thing, a couple hundred times a second, they're reading from it. And so what you're trying to do there is you're like, okay, I'm changing it as fast as I'm reading it. It's hard to write that then to a database, for instance. But it's also then hard to serve both sides of that because, like, if you have 36 cores and you got a big network card, you got the available compute power, but it's actually sharing that bit of memory that's hard. So we used it for that. And I mean, you can do that in other languages, and Java has lots of options. It's not like this is obviously the only one, it's been done forever. But it happens to be like, if you come from a language like Node, or you come from a language like Python, and that's the type of work you're doing, all of a sudden you're like, oh, I don't need an external database anymore.
And I'm picturing that algorithm, like all of the work to make that transaction processing possible. It's probably 4 lines of code.
It was, I don't even know if it was that. Yeah, exactly. We were like, number of processors divided by 4, go routine, and just wait for them to come back. That was it.
Exactly. And then inside the code key, some places, a loop that goes over a channel in, and then that channel in inside of that before you have a channel out as a transaction.
Yeah. I'm a big like right tool for the right thing kind of guy, so I'm never going to preach a language, but like for some of the use cases we have, it just happens to be very convenient. I mean, Java, for instance, is equally as good.
You feel like pauses.
Yeah, one of the things we do is we sell software. You know, there's always a little bit of like what's new and sexy, right? People don't want to come to us and buy something that they could have bought, you know, in a language from 20 years ago because in big companies, one of the things they do is they use the newest tools. It's because they're always competing and hiring people. And guess what? We love to use new stuff a lot of the times. So, you know, it's a marketing thing for big companies as much as it is. Now, I'm not saying it's not awesome. It is an awesome tool for the job we're using, but I don't want anyone to think like, I'm not doing it in language, I actually don't really care. But it just happens to be really good in this case. So.
Did you consider a Wixer?
We did, and I think it would have been just as good. We didn't end up doing it, I think, because it felt, well, we liked the compilability story on this one. We liked a lot of that kind of stuff about it. And, you know, Mixer and Erlang have been around for a long time and have still not seemed like, you know, I couldn't really find a huge company back there. And so when we're out selling stuff and I can say like, hey, do you guys use Docker? Sweet, you're ready to go. It was a help on the sales pitch. I could have made the same pitch for Java. You ever heard of Netflix? You know, they have bigger problems than you. They run Java and all their stuff is open source. Our big actual discussion internally was really more between, what's that new language in Java that Dan really liked?
Closure.
What was it?
Colin. Scala.
It was called certainly K.
Oh, no. Yeah, it's
Kotlin. And then we looked at that and we're like, well, it seems like it's, unfortunately, I think it was that lazy. It was really the only company using it. It was mostly for their tooling. And so we were like, I don't know. Does anyone actually like Jira? So it's like, that's the problem with Kotlin, you know? So, sorry, you gonna say, Jeff?
I was going to say, Brian, you're still bitter about Jira, so.
I mean, everybody uses it.
That's a good
Yeah.
Colin is actually, he's seeing more usage soon because Gradle, the excellent tool.
Oh, yeah, that's great. Yeah, that's a good one.
Now has a Kotlin language you can build. And the nice thing about that is that the big problem with Gradle has always been it's written in Groovy, it's dynamically typed, and therefore you can't get any IntelliSense when you're writing. By using Kotlin, suddenly your builds are pretty much the same length, but they're typed.
If you guys don't follow Mark on Twitter, like half what I told you tonight, I probably actually got from him, but it's Data Mark Miller. He's actually pretty fun to follow. So really cutting edge of the shit. But yeah, so totally. So yeah, I think it was as much like a sales thing for us as everything else, but I think we've been really happy with the choice. We really like it.
No. Did you consider Closure?
No.
No.
I don't know why.
What about Rust?
What's that? we did actually kind of look at that a little bit. It was again, it was like, well, it's going to be easy to say like everyone's moving to Docker, so Docker internally in a lot of places, like the thing that you really want to go to, they're spending money moving to it. So it's kind of easy to go in and sell them, you know, something that is awesome. It also feels like it's in line with their corporate, you know, strategy. And that was kind of funny.
I'm interested because I have a friend who recently moved from New York City to San Francisco to work on Corrigan.
To work on Go. See, that's the thing. And so that's the other side of it. You know, if you haven't worked for a company like that, with them, it's marketing too. I don't know if Rust has like, this is just as an aside, but I mean, when we built the last game platform, we did it in Python, which was, you know, why sort of hate Python these days, and I don't feel like it, but you know, we knew the challenge we got into it. You know, I don't think we understood this stuff as much viscerally as we do today, but what was I going to say? But part of it was because it ran on Windows. And so another really nice thing about the Go stuff is like it is cross-platform. I think at this point, it would be hard for us to consider anything that wasn't. I think it's that way for you guys at Apprenda too.
Yeah, it's stepping up like that.
Yeah, I mean, why would you not? I mean, so also Microsoft's making it a little easier, so that's nice. Anyway, any other questions?
More?
Cool. If you're in Saratoga, we don't have beer on tap, but we're across from 5 different bars, and Jeff's always happy to buy you a beer. So come and say hi. And on Friday night, we're usually at 7 North Pub by at least 4:45. So come visit. Thank you.